Hello and welcome to another video by Help You Excel. Today I'm going to show you how to create your first database, having no experience at all with databases before. I'm going to build it in Microsoft Access, so there will be some specific how-to in terms of Microsoft Access, but I'm also going to be talking a lot about just general design principles that will apply to whatever relational database engine you decide to use for your database. So let's dive right in. Okay, when you first open Access, it's going to look something like this. It might look slightly different depending on the version. I'm on 365, so this is what it looks like for me. But you're going to see something like this. So you're going to open it, and it's going to give you the option to open files you've opened in the past. You can go down here, you can open existing file, browse, find it wherever you've got it saved. But if you want to create a new one, it gives you all these templates. Some of these are quite good, but we want to design our own. So we're going to go here to blank database. And then the temptation is to just click create. If you do, it's going to give it this generic name, and it's just going to default to saving it in your documents folder. If you want to give it a specific name, you can just type a new name here. I also want to save it somewhere different, so I'm going to save it somewhere different. New folder. Call it catalog. First database. Okay, and then we're going to click create. Now Access is going to default to putting you in a table. I really hate that it does this because it puts you in the table and it allows you to just start clicking to add columns, which I really don't like. I always close that and then I start from scratch. So to create your first table, you're going to go here to the Create tab and you're going to tell it you want to create a table. And it puts it in data entry mode. I don't want that. I want design mode. So you have to right click and hit design mode, give it a name. For this first table, what I usually do is I create a template table that then I copy over and over again. And I'll show you what I mean by that. I call it Z template so that when it lists your table names over here, it's always alphabetical, so calling it Z template puts it on the bottom so it's easy for me to find. Okay, this is actually good. Every table should have an auto number field that is your primary key. And if you're not familiar with what a primary key is, it is just a unique number, usually a number. Best design is a number, but it can be text. But it's a unique value that uniquely identifies a specific row in a table. And you'll see that more as we go through. Okay, but if your Access didn't automatically do that, I'm going to show you how to do that. So all you have to do is here where it says field name, type in your field name. I always call my primary key just ID. That's kind of the industry standard. It can be anything you want it to be. Whatever you choose, I recommend that you choose some sort of consistent naming pattern so that you always know this field on my table is the primary key without having to look at the design. You just know if it has this name, it's the primary key. Okay, you've got different data type options here. For a primary key, I always do auto number. Almost without exception. There are some very rare exceptions when I might do something else, but that's pretty uncommon. Okay, once you've done that, with that row selected, click on the primary key button, and that is now your primary key. And you can see that with this little symbol here on the left. It's supposed to be a key. It's kind of hard to tell that that's a key. Okay, every table that I create, I'm going to have 3 fields. So that's why I do this template table. Second one is going to be, I call it inserted. Data type is date time. And what this row is going to be, it's going to record the date and time that each row is created in the table. Okay, so down here are different options that you can set for whatever field that you've selected up here. So I'm going to give this a default value of now, and what that will do is it'll put in today's date and time automatically. I'm going to make it a required field, which means that field can never be left blank. If you try to save a record with that field blank, it will throw an alert at you and it will yell at you. The last field that I always have on every table is an updated field. Okay, I'm going to default it to now, the same as the inserted. But what I'm going to do is anytime a value changes on a row, I will record the date and time that that value was changed in this field. So when a row is first added, these two values will be the same. But if you then later go back and change something in that row, then the updated value will change to the current date and time. The inserted value will remain the date and time that it was first inserted. Okay, I'm going to save this. You can click the save button here. I usually right click and do save. And then I am also going to put in, Access doesn't call it this, but it's basically a trigger, so that anytime something changes on this table, this field gets updated. Depending on your version of Access, you might not have this option. The newer ones all do, but you just click here, create data macro, and I'm going to say before change. And I want to set a field value. Now the name of the field is updated, and I want to set it to now. So what this will do is every time before a change is made to a row in this table, the field called updated will be updated with the value of now, today's date and time. So I'm going to save that, close it. That's my template table. So every table that I make from now on, I'm going to use that as my starting point. Okay, now the database that I'm going to design, I'm going to show you how to design, is a very simple order database. So keeping track of customers, a catalog table, and an order table and an order detail table. So it's going to be customer, item, order, order detail, 4 tables. Okay. So first I'm going to just start with customers. So all I'm going to do is I'm going to copy this table because it's my template table, and then I'm going to paste it. And then it asks me for a name, customer. Now you might be tempted to say customers, which would be fine. It is kind of accepted standard practice that your tables, your name refers to what a single row on the table is. So yes, the table as a whole is going to be a list of customers, but each row is one customer singular. So you would name your table customer singular. Okay, so I'm going to copy that. And now I'm going to go here, I'm going to right click, go to design view, and now I'm going to add my fields that apply to a customer. Okay, so first field I'm going to do first name. Okay, data type is short text, which Access defaults to. I usually set a first name field size 50 characters long. I've never encountered a first name that's longer than 50 characters. It's a good design practice when you create fields to create them as small as you can get away with, because it will use less space on your drive, it'll make searching the field faster, it'll make indexing the field faster, those sorts of things. Okay. Now we've got all these different options down here. I can give it a caption. I actually don't like doing this because anytime you write a query, it tries to use that name, and I don't like names with spaces. Which brings a point up that I did not mention. It is best practice to not use spaces in your field names. The reason for that is some database engines won't allow it at all. Oracle will not allow spaces in field names at all. SQL Server will, unfortunately. MySQL will not. Access will allow it, but then whenever you refer to that field in a query, then you have to put a bracket around it like this. versus if you just don't use any spaces, you can just do this, no bracket. It makes writing queries and all those things easier. So do not put spaces in your field names. What is acceptable is underscore. That's kind of a common practice. I've seen examples where field names are always capitalized like this with underscores. It doesn't really matter what you do, just be consistent. So I'm using what's called camel case, and I'm going to consistently use that throughout. So what that means is the first word in my name is not capitalized. Every subsequent word in the field name is capitalized. So when I do my next field, which you can probably guess, oops, caps locks, last name, also going to be short text. I'm also going to make it 50 characters long. I am going to make it required. And I'm going to make it so you cannot have a zero length. I'm going to do that here too. Which brings up a point. The difference between null and empty set. So when you say required, it's telling you that you cannot have a null value. When it says allow zero length, now I'm telling it that you cannot have an empty set, which I'll get more into what empty set is a little bit later. But they are different things, and I'm requiring that that field be filled out. There has to be at least one character in this field for both first name and last name. I'm going to add one more field for customer. Also short text. For email address, I'm going to do 100 characters, which should be plenty long for an email address. I'm going to say required, not allow zero length. Now, I want this email or this customer table, I don't want any email addresses to appear twice. Okay, so every email address has to be unique. So what I'm going to do here on the indexed, down here at the bottom, you've got three options. You've got no, yes, duplicates are okay, yes, no duplicates. So I'm going to choose yes with no duplicates. And I'm going to save this. A field name is missing. Oh, yes, because I was goofing around in here. We need to delete this and save it. Now, if we go datasheet view, I can type in Paul Sassy, Paul at huxl.com, and you will see it automatically did a default today's date and time, and you will see the updated is slightly different than the inserted, because when I very first start typing, the inserted is exactly the same, but as soon as I go to another field and I type in something different, then actually let me finish. I'll show you at huxl.com. What's going to happen is as soon as I leave this row, the updated value is going to change. So you can see now the updated value is slightly different than the inserted value. Okay, which also brings up another point, what's called the dirty state. So if I click in here, you see there's no little icon on the border, but if I click in here and I start making a change, see the little pencil? That means this row, this record, is in a dirty state. There's a change that is pending that has not been saved yet. Okay? As long as I stay in this row, that pencil is going to stay there now. As soon as I go to a different row, the dirty state is gone. This row is now saved. So unlike a spreadsheet, you don't need to, as you're changing data, keep clicking save all the time. It does it for you. Okay, dirty, not saved, saved. Okay. What you do have to save is design changes. So if I were to go in here and add a new field, it asks me, do you want to save the table? It's not asking me to save my data. It's asking me to save my design change. And if I click no, it's not going to let me open the table. And if I close this and I click no, that phone number field was not saved. If you look in here, the phone number field is gone. But if I open in Datasheet view, all the data that I've typed in so far is still there. Okay, so when Access gives you that warning, do you want to save? They're not asking, do you want to save the data? They're asking if you want to save your design changes. Because I made that email address a unique field, if I try to type in the same email address, it doesn't do the check until it tries to save. So this field is dirty right now. See the little icon? As soon as I try to commit that or go to another row, now it's going to tell me the changes you requested were not successful because they would create duplicates in index, primary key, or relationship. The reason I cannot save that is because I am duplicating email addresses. Now, if I had done that, now watch when I commit, no problem. Same first name, last name, because they're not indexed, but different email address, so it allows me to save it. I'm going to type in just a couple more. So we have a little bit of data to work with. Going forward. Okay, now, the other thing to note, we made this ID an auto number field, and you'll see as I add more rows, it just automatically goes to the next number, and it will never reuse numbers. So if I delete this, number 4, and retype her, it's number 6, and it won't let you try to type in something different. I'm typing 4 on my keyboard, it will not let you change it. Okay, so these auto numbers, all it does is it makes sure this number is unique for the entire table. And a good example of when that's important, we'll go back to where I did this. Paul Sassy is an unusual name, but if you did have 2 different Paul Sassy's as customers, and then they have orders, this allows you to know, okay, this order goes with this Paul Sassy, this order goes with this Paul Sassy, because when we save the customer information of the order, we're going to refer to this primary key. So it allows you to uniquely identify a row on your table, so it has to be a unique number. So going back to why I called this customer, this row, one row in my table, tells me something about a singular customer. So that's why my table name is customer. Okay. Another design principle that I have alluded to but haven't discussed specifically is fields versus records. So a field is some specific nugget of data. Okay, so first name is a field, last name is a field, email address is a field, inserted is a field, updated is a field. Okay. Every customer has to have a value for each of those fields. A record is one row on the table. So think of like if you have a Rolodex, if anybody remembers Rolodexes, where there's a index card for each of your customers. Each one of these rows is like an index card in a Rolodex. Okay, so these are records, these are fields. All right, so we've got our customer table. Now we need to have some sort of table where we record our products. So I'm going to copy my template again. As a starting point, I'm going to paste it. And again, each row on this table will refer to one particular product. So I'm going to call it product singular. Now I'm going to create a field called SKU, which is like a part number. So every product will have a unique SKU. So I'm going to make it indexed with no duplicates. Even though this field is unique and it will uniquely identify my products, I am still going to let the primary key on my table be an auto increment. That's just a best practice. That's just the best way to go. Okay, and my SKUs, I'm going to make this 20 characters long. That's plenty long for a SKU. That gives you a lot of possible products, especially if it's alphanumeric. 20 characters is plenty. Now I'm going to do product description. Okay. I am also going to make this required and not allow an empty set. I'm going to make this yes indexed because I want to be able to search the product description, but duplicates are okay. Okay. Now, you could add more information like volume, weight, packaging. I mean, there's all kinds of things that you could add. I'm trying to keep this simple as a first database example. So I'm going to leave it that way, just a SKU and a product description. That's it. Okay, so we'll open up in datasheet view. And let's do a 1, 2, 3, ABC is my SKU. And we'll say this is milk. I've gotten on a kick when I do sample databases to use like a grocery store. 2, 4, ABC, cheese, Z, 1, 2, 3, crackers. I'm just going to do a few products. Now, if I try to reuse a SKU, what do we want to do? Let's say wine. It's going to yell at me. We can't have the same SKU because I made it a unique index. So let's do 444 is wine. Let's do Dr. Pepper, Coke, ibuprofen. So that gives us a few products to work with. Okay. Now, every time a customer places an order, we need to keep track of that. So we need to make an order table. I'm going to copy my template again, paste. Each order is going to have one line on this table, and each line on this table will refer to just one order. So I'm going to call it order singular. Now here's where we get into some design principles. The first field that I'm going to put on here is customer ID, and the value of this field is going to be the primary key of a customer. So if John Doe places an order, we're going to put number 5 there because that refers to John Doe. If Paul Sassy places an order, it'll be number 1. If Mary Jones places an order, it'll be number 6. That's called a foreign key relationship. And the data type has to match. Well, auto number is long integer for my data type. So for a foreign key relationship to work, I go to number and it defaults to long integer. I do not want a default value of 0. I do want it required, and I do want it indexed, which it did default. Access, if you name a field something underscore ID, it will always default to making that an index field, which is good. Okay. Now, this table is 1 row per order, so it's not going to list every item that was ordered on an order. It's just going to be 1 line per order. So things that is related to the entire order. So something like order date, and I do want that to be required. I'm going to do a default value of int now. So that will default the order date to today's date. You'll be able to change it if it's not today's date, but it'll default to today's date. You can also do things like put a validation rule in here. Okay, so this will not allow you to future date an order. Depending on your situation, maybe you need to be able to future date orders, but in my application, customers cannot order things in the future. So when I say validation rule less than now, remember now includes the date and the time. So if I put in a date of February 4th, which is today's date, as you can see, it will pass. It'll be okay because February 4th, if you just put in the date, is referring to February 4th at exactly midnight. Well, it's February 4th at 10:54. Therefore, it's going to be fine. And then validation text, you can display a custom error if they validate this rule. Okay, and I do want to make this indexed. Okay, for this simple example, that's all I'm going to do for my order table. I know who placed the order, and I know the date that they ordered. Now, in order to know what they ordered, we're going to create another table which will have one row per item on a given order. Okay, so let's save this, and let's go to Datasheet View. Now, before I enter any data in here, I want to create my first relationship. Let me show you how to do that. So I'm going to go to Database Tools. I'm going to go to Relationships. And I am going to drag in. You can just click and drag. Order and Customer. And when you look at them side by side, it becomes pretty obvious what the relationship is going to be. Here's the ID field on the customer table. Oh, over here I've got a field name, custom ter. I just realized my typos. I'm going to fix that before I make my relationship. Customer. I got the T in the wrong place. Customer. Okay, there we go. So we're just gonna, all you have to do is click and drag. When you let go, you will have these options. What I want to do is I want to enforce referential integrity. And I'll explain what that means. Before I do that, let's create the relationship without that first so I can show you another design principle. Okay, so I have created my relationship. I've got a customer ID that's related on my order table. I'm going to save that. Now I'm going to go in here. Let's open both these tables. So Paul Sassy is going to place an order. So we're going to say customer number 1. And he's placing an order today. There we go. We don't know what he ordered, but we know customer number 1 is placing an order today. And customer number 1 is Paul Sassy. Customer number 2 is going to order, I'm going to intentionally violate that validation rule. I'm going to say 25. And because I put in custom text, if you remember, orders cannot be future dated. So you get that specific message instead of accesses generic message. I'm going to change this and say I meant 2-1. So customer 2 placed an order on 2-1. Now, if you'll notice, customer 3 and 4, not valid customer numbers. Because I did not do referential integrity, it will let me put customer 3 in there, even though there is not a customer 3. This is called an orphan. Okay. These two tables have a parent-child relationship. Here's the parent. There's only one customer or one row for each customer. The order table, on the other hand, could have multiple rows for the same customer. So this person, maybe they placed an order back in November, and they placed an order in December, and they placed an order in January. So customer 1 can be in here multiple times. Okay, so that makes this customer 1 can only be in this table one time. He can be in this table multiple times. So this is a one-to-many join, and the table with the many is called the child. The table with the 1 is called the parent. Okay, and when you have a value in your child table that does not exist in your customer table, in your parent table. That's called an orphan. So this number 3, that value does not exist on my customer table. It is an orphan. So that number 3 tells me nothing. I have no way of knowing who that customer is. And I'll show you another thing that will happen too. You see on this table, there are 6 records. Okay, if I try to do a view, or what Access calls a query, yes, we're going to save that. Create, we're going to create our first query. Go to Query Design, and we're going to pull in Customer and Order. And you'll see, because we did the relationship, it makes that reference for us, makes that join for us. So I go here, first name, last name, order date, and all I'm doing is I'm just click and dragging what I want to see. So you can shift and you can highlight multiple, drag them down at the same time. Order date. Go to datasheet view, Paul Sassy, which is much more friendly than just showing their customer number. I can show that too. Customer 1, or Paul Sassy, has these 4 orders. Customer Bob has this order. Notice I'm only getting 5 results. On the order table, I've got 6. This one is not showing up because customer 3 doesn't exist. We have no idea who customer 3 is. We don't know their name. We don't know anything about them. That's an orphan. Okay, so I'm going to delete that row for right now. Close this. I'm going to not, let's say this. View customer order. And that's kind of my naming convention. I always start queries with v underscore so I can separate those from tables. It's not required. I think it's a good practice. All right, so now I'm going to edit this relationship. And to do that, it's a little tricky to get your cursor placed just right. But you right click on the line, go to edit relationship, and now I'm going to click enforce referential integrity. You'll notice it gives me the one to many. So you know that referential integrity is enforced. You know this is the one side, this is the many side, this is the parent, this is the child. We're going to save that. Now if I go into the order table and I try to type in a 3, I can't do that because it's telling me 3 does not exist in my customer table. Okay. Now let's make this 4 instead. 4 also does not exist. 5 does though. Okay, so this order is for customer 5, which is John Doe. Okay. The other thing that your referential integrity does, if I try to delete John Doe, it will tell me I cannot delete John Doe. It won't let me because John Doe has placed an order. If I delete John Doe from the customer table, I create an orphan on the order table. I don't want that. However, Mary, customer 6, has not placed any orders. So if you entered her in mistake, you can just delete her, no problem. You can delete number 7, no problem. 1, 2, and 5. So these guys we cannot delete because I've got orders. Bob has orders. John has orders. So by doing referential integrity, you make sure that you cannot have any orphans. Okay. You will also notice this little plus sign was not here before. Microsoft Access does this by default, and I actually kind of don't like it, but it does it anyway. So what it does is it does a sub data sheet. So because there's a relationship between the customer and order table, if I expand this, it will show me all of my orders for Paul Sassy. And if I want to create a new row, just like that, I have created a new row in my order table. So if we refresh this, now there are actually 5 orders for customer 1, which is Paul Sassy. It will also let you delete out of here. So now I've deleted all the orders, and you'll see that shows up right away. Hit refresh. Now if I wanted to, because there's no longer any child records, I can delete Paul Sassy. I'm going to put Paul Sassy back because I want to be in there. Okay. Now we need to be able to actually order things. To do that, we need to create one more table. I'm going to copy my template again, and I'm going to call this order detail. So this one is going to have 2 foreign keys. It's going to have the order underscore ID. I do not want 0 to be the default value. I do want it to be required. And then I also want the product ID. Again, I do not want 0. And yes, I want it to be required. Breaking my naming convention. Okay. Now, I used a data type we haven't used before. Currency, pretty self-explanatory. 2 decimal places. Default value, I do not want it to be 0. I do want it to be required. I do not want that to have a default. I do want it to be required. Now, the reason I don't like these to have a default value of 0 is 0 is a value, which kind of, in a way, negates the required property. I want the user who enters data to have to put in a price. I don't want to give them the option to accidentally leave it blank. And if you give it a default value of 0, they could accidentally give a customer a 0 price, and the database is not going to enforce any rules saying that that's not okay. Whoever the cashier is or whatever, they could put a 0 in there manually, but they have to intentionally put in a 0. They can't just leave it blank. Same thing with the quantity. I don't want them to be able to just accidentally, oops, I left it blank and the quantity is 0. Because you can't, it doesn't make sense to order quantity 0 of something. Now I'm going to introduce a new kind of data type. Before I do that, I'm going to delete that right now. I'm going to save this. And I'm going to do this subtotal, and I'm going to make a calculated field. What this does, calculated fields, the user cannot type anything in here. It's going to use 2 fields to create a calculated value. So what I'm going to do is I'm going to take the price times the quantity, and that will tell me the subtotal for that particular item. So when you choose calculator, you're going to get this pop-up. You can just double click down here, or you can just type, and you'll see it gives you some IntelliSense. I want that one. Hit tab to accept. So this calculation is just going to be price times quantity, and it'll give you a subtotal. Okay, and I want the format to be currency. Okay, so let's look at what this is going to look like. I'm going to open 2 tables. This one and this one. Okay, so currently we only have 2 rows on our order table. We got order number 2 and order number 7. So we're going to do order ID 2. So that tells me this line refers to that order on the order table. and they want to order, let's say, product 4. So product 4, and the price is $1.40, and they want a dozen of them. Now you'll notice as soon as I tab over, it does the math for me. The subtotal is $15. Now I realize when you're using it in this way, it's very much not user-friendly to have to go look and say, okay, what order am I talking about? What product am I talking about? I will show you, even just through the tables, how you can make this much, much more user-friendly. I'm not going to get into forms today, but when you start creating forms and interfaces, this becomes much more user-friendly for entering your data. I'm just showing you how the data itself is structured. Okay, so I'm going to stick with the same order. They also want to order something else. Let's say they want to order some cheese with their wine, which is product number 2. Cheese is 75 cents, and they want 2 slices, so that's $1.50. Same order. They also want some crackers, so that's part number 3, or SKU number 3. Sorry, not SKU number 3. It's primary key number 3. Let's see, they're a quarter a piece, and they want 24 crackers. Okay. Now for order number 7, which order number 7 belongs to customer ID 5. Customer ID 5 is John Doe. So order number 7 is for John Doe. Let's see, what does he want to order? He wants to order some milk. And we're having a sale on milk. He wants 2 gallons of milk. Order number 7, he also wants some Dr. Pepper. Part 5. What have you. Okay. Now, I have not yet created a relationship. I should have done that before I started entering data, but we're going to do it now. Relationships. Okay. So we're going to drag this in here. First relationship is order ID goes to order. I want to enforce referential integrity. I'm going to save it. And then product ID. So we go like this. Product ID goes to the ID field on the product table. Enforce referential integrity. Save. Okay. Now, a side effect of us doing those relationships, remember the sub-data sheets? So here's John Doe. This has 1 row for every order he's placed. And you'll notice we have an expander again. And we can see 1 row, or 2 rows, sorry, for the items that were on that order. So you can see $2 on product ID 1, $3 on product ID 5. So you can see all of John Doe's orders that way. And if you want to do a new one, that creates a new row, and then you can go in here and it will automatically update the order ID. Now all you have to do is product 12. I don't remember how many products we did in here. Eventually, I'm going to type an invalid product ID, and it's going to yell at me. Not there yet. I think this will do it. There we go. So there's only 7 products. So this customer, was this John Doe, on February 4th, ordered some of every product in our catalog. Okay. So even just a few minutes, I mean, you can see this is not super user-friendly, but it is functional. It's a basic ordering system where you can keep track of your customers, their contact information, different orders, and different items that they have ordered. Now, what I'm going to do to make this a little more user-friendly, again, I'm not going to get into forms, but we can make this more user-friendly by, yes, let's save that. doing one little thing. We're going to go to Design View, Product ID, and I'm going to go to this Lookup tab here in the bottom. I'm going to change this to Combo Box. And what I want to do is, instead of them having to know the product ID, I want them to be able to select it from a list that a human can make sense of. So I'm going to go and I'm going to click the dot, 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 and I'm going to drag in the product table from over here. I want the primary key, and then I'm going to do SKU and a space and product description. You can test it, make sure it looks okay. So 2 columns. This is the SKU. This is the product description. That looks great. When you close it, it's going to ask you, do you want to make this your SQL statement? And I say yes. So I'm not going to go into SQL for this video, but just real quick, select and then field name. So the ID field, comma, SKU, and product description as product from the product table. Okay, so this query, as we saw, has 2 columns. If we run it, 2 columns, 1, 2, right? The bound column is going to be the column that stores the value. Okay, so going back to this, the value that we want to store is the product ID, which is the first column. Okay, got to tell it there are 2 columns. Now, column widths. I'm going to set the first one to 0 because I don't want to see that primary key. And I'm going to set the second one to 4. So you just do 0 for the first column, semicolon, 4 for the second column. And I'm going to tell my list width to be 4 also. So now when I open this, instead of just showing me the primary key for the product, I'm seeing the SKU and the description. Okay, the value that is being stored is still that same number. You can see that if I change this back to text box, yes, product ID is still the value. I'm just displaying something that's more user friendly. The SKU and a description. Okay. The other thing this does now is I've got this lovely little drop down. I don't have to remember that wine is part number whatever, Coke is part number whatever, cheese is part number whatever. I can just choose it from a list. So it makes it much more user friendly. So at this point, we've got a pretty functional little database. So if we go to customer and we need to put in a new customer, Mary Smith, Mary at huxl.com, and she wants to place an order. Okay, and she wants to order some cheese. It's whatever. She wants to order some Coke. So it's still not the best. Visually, it can definitely be made more user-friendly with a form. But for a very quick, how long has this been going? 20 minutes? I guess it's been an hour. But even so, within an hour, I was able to create this fairly functional database to keep track of orders. And I was explaining as I went, if I were just doing this on my own, I could have easily gotten to this point within 10, 20 minutes. So this is the power of Microsoft Access. You can do some pretty functional things very, very quickly. I hope this also helped you understand better some of the design principles, how a relationship database works. I do want to show you one more thing. Create another query. We're going to go query design. And this time I'm going to drag in all of my tables, so I can just shift click, drag them all in, and because I've done my relationships, everything is drawn out for me, which is really great. So I can do name, last name, and name, email address, order date, SKU, subtotal. So just very, very quickly now, this is a list of every customer that's placed an order. It's got their name, email address, the order date, and the various things that they've ordered, just in one nice clean list. And you can filter, like if I just want things that have been ordered today, there's all the orders that have been placed today. You can feed this into a report, you can export it to Excel, and whatever you need to do. I know I threw a lot at you very, very quickly. I hope this video was helpful to you. If you would like more help, you can reach out to me. Visit our website. There's more videos like this. I'll be doing more all the time. If you would like me to build something for you, you can also reach me at the email address here or through our website. If you like this video, don't forget to like it. And if you want to see more like this, don't forget to subscribe. Thank you.